In this problem, we are going to do gas stoichiometry, which requires both the use of stoichiometry and the ideal gas law. This problem reads, Mr. Mole did an experiment in his chemistry class where he reacted magnesium with hydrochloric acid in a test tube. He put a balloon on the test tube to collect the gaseous product. What volume of gas should have been collected when he reacted 2.19 grams of magnesium with excess HCl? The temperature was 27.5 degrees Celsius and the pressure was 0.879 atmospheres. Because in this problem they're asking for volume, we first have to do the stoichiometry, or the BCA table, and then we will do the ideal gas law, PV equals nRT, second. To begin, we need to have a balanced equation. To balance this equation, we first put a 2 in front of the HCl, and all other coefficients will be 1, and now it's balanced. The number that we need to begin with is 2.19 grams of magnesium. So we will first change those grams into moles. You can use the mole roadmap, which says we should put 1 mole on the top and the molar mass of magnesium, 24.3 grams, on the bottom. When you do that math, you should get a number of 0.0901 moles. That is the amount that we're going to put into our BCA table. So we have 0.0901 moles of magnesium, and the problem says we will have excess hydrochloric acid, and we know that we always start with 0 products. We assume we're going to use up all of the magnesium so that we have none left over. Because magnesium, magnesium chloride, and hydrogen all have the same coefficients, we can transfer that same number in the change row, just that we are adding them because products are being made. To figure out how much hydrochloric acid is needed, you would cross multiply 1 over 0.0901 and set that equal to the coefficient 2 over x. When you solve for that problem, you get 0.180 moles. Then we can just complete the BCA table, and we end up with 0.0901 moles of magnesium chloride and 0.0901 moles of hydrogen. Next, we're going to use our ideal gas law, which is PV equals nRT. Now, because it's the ideal gas law, we can only plug in information for a gas. So when we look at our balanced equation, our substance that is a gas is hydrogen. So we're going to use all of the information for hydrogen to plug into this equation. We also know that the final question is asking for how much volume. The pressure is 0.879 atmospheres times V, because that's what we're solving for. N is the number of moles of hydrogen gas. So we pull that out of our BCA table, 0.0901. R is the gas constant. It's always 0.0821. And temperature, remember, needs to be in Kelvin. So we'll have to take our 27.5 degrees Celsius and add 273 to get 300.5 Kelvin. We'll plug that in and then solve for V. When you do all of this math, you should get V is equal to 2.5 liters, and that is your final answer.